All right. Hello, I think we're on. Can everyone hear me? Yes. Okay. Well, good afternoon, everyone, or good morning. Thank you all for joining us for From Steam to Sensors, Rail Innovation Then, Now, and Next. I'm Betsy Cantwell, President of GoRail, and I'm delighted to welcome you all. For those who may not know us, GoRail is a national nonprofit dedicated to educating the public and policymakers about the public benefits of moving freight by rail. We also lead Rail Champions, a nationwide network of grassroots advocates who speak up for policies that keep freight rail efficient, safe, and innovative. We're especially excited to partner for this program with the Association of American Railroads during their Innovation Week and against the backdrop of our nation celebrating its 250th anniversary. So, why dedicate a program or a whole week for that matter to innovation? I'd say the answer and our through line for today's program is because innovation is how this industry has continuously solved problems for nearly 2 centuries. Every generation of railroaders has asked the same question: how do we do this better? In the 1800s, the answer was building America's first real-time network, installing telegraph wires along tracks to carry constant updates to trains, or about trains moving across the network. By the 1890s, doing better led railroads to be among the first to adopt what we call proto-computing technologies like punch card tabulating machines to process logistics data. And at the middle of the 20th century, freight rail was among the first industries to adopt large-scale mainframe computers for tracking the network. Fast forward to the mid 2000s with the initial development of positive train control, a technology that can automatically stop a train to prevent accidents. Today, it's technologies like artificial intelligence, advanced sensors, drones, automation, and predictive analytics that can identify potential issues long before a human eye ever could. So the technology and tools that have changed dramatically, but the goal and the mindset of doing better is consistent. And that's why today's conversation matters. Innovation isn't new to railroads. It's been part of our story from the beginning. So we have an outstanding panel with us today, and each speaker represents a different part of that chapter in rail innovation. We'll begin with Chris Holland, Executive Director of the B&O Railroad Museum, or should I say, as the official announcement went out yesterday, the National Museum of Railroad History and Innovation. And next, we'll hear from Josh Ragland, Chief Sustainability Officer at Norfolk Southern. Josh will share about how one of America's largest railroads is using technologies like mobile carbon capture and digital inspection. Then we'll be joined by Guchan Ozbilgin, Head of Perception at Parallel Systems. Guchan is helping to develop autonomous rail technology. After that, we'll hear from Dominika Dubinsky, Assistant Director of Operations at CPKC. And she'll talk about the railroad's development of broken wheel detector technology. And finally, we'll wrap it up with Devin Lids from the Association of American Railroads, who will connect these these innovations to the public policy framework needed to support continued investment and technological advancement. So before we start, just a couple of housekeeping notes. We are recording today's session and we'll distribute it afterward to everyone who registered. And then we'll also save time for Q&A at the end. So please submit your questions in the chat or the Q&A box throughout the discussion. And with that, let's get started. Chris, thank you for being here. And I'll turn it over to you.
Thank you. I really appreciate the invitation, and it is great timing with Innovation Week and with the fact that we have launched our new name. I am the Executive Director at the National Museum of Railroad History and Innovation, formerly the B&O Railroad Museum, and I am going to talk very quickly and show you slides from our collection, kind of taking us from the very beginning up to close to modern day. And I just will remind everybody that the B&O Railroad, our nation's first common carrier railroad, was chartered on February 28th, 1827. So next year is the bicentennial of the railroad industry. And the first stone was laid on July 4th, 1828. So we plan next year to actually open that stone. We have it. It was a time capsule of its time, and it's never been opened. So it will be interesting to see what was in it. So I am going to show my slides, hopefully, since this is really a visual presentation, and move us forward. And so when you, that will be our new entrance for those of you who have been here. And there we go. So, very quickly, these are all pictures from either our collection or our archives. But when we think about the railroad, as Betsy said, it was our first innovation, a huge engineering innovation that moved the nation forward. And before that, people used Conestoga wagons and they used the canal system. And then we ultimately went to basically putting cars on rails and having them pulled by horses, which made it, easier, and it avoided the wear and tear to an extent, and they could go a little bit further. And then we went to steam. And so then we finally get to the steam engine, and over on the left is the Peter Cooper's Tom Thumb. And it was the first American-made locomotive. It was an experimental grasshopper type locomotive that used wood as fuel. And for those of you that know about the Tom Thumb, there was always a legendary race that the Tom Thumb raced a horse. The Tom Thumb was winning, and then something broke on it, and the horse won the race, but everybody saw that steam was going to be the way to go. In the middle picture, we have, early, wood-burning steam engines were eventually replaced with coal-burning engines. And this one with a horizontal boiler, like the number 25, the William Mason, is pictured right here. But also the William Mason, just for those of you, it's a fan favorite because it is the locomotive that pulled President-elect Lincoln when he was on his way to his inauguration. There was an assassination threat, so that locomotive, they snuck him through Baltimore at night with that locomotive. Then we come over to the introduction of the Wooten firebox, and it made it possible for heavy steamers to burn anthracite coal, which is rich in energy and was longer lasting. And so the B&O number 45 Mikado, which is pictured right here, is an example of an anthracite burning engine with a Wooten firebox. It is also, just as an FYI, the very first engine that was built by the US government when they took over the railways during World War I. And the thing that's pretty amazing about it is they built it in 28 days. When you think about it today, they couldn't even answer the phone in 28 days, but that's a whole nother thing. Then we end up with getting more evolution in these, steam engines were eventually replaced with diesel electric locomotives. So the B&O number C10 pictured over here, they were developed at the turn of the century, and this engine received its power from overhead trolley wires. So in our area, it'd be around the Fells Point area. And because they don't produce exhaust, engines like this were often great for the city where steam was banned. But they were obviously restricted by the overhead wires. And then, to solve this, the industry turned to diesel engines. And this is the CNJ 1000. The government also had told the railroads around that time that you've got to start thinking about moving away from steam. And this was the very first prototype diesel electric engine that was a switcher engine, and it was made to show the railroads that it could do the work. And it was built in 1925, so it actually just turned 100 years old last year, and it actually just came out of our restoration shop a few years ago. So then we move over to diesel electric engines continuing and becoming more powerful so that they can move mainline passengers and freight service. So the number 51 pictured here was built in 1937, and it was the first streamlined diesel electric passenger engine. And in 1937, you might think, well, what else was going on at the time? That's when the airline industry was really starting to, I don't want to say take off, but, take off. And that was sort of the railroad's answer to that, kind of the response. So, we continue to look at specialized engines, and, and they were starting to be constructed for specific tasks. So we have Ross Winans number 217, and it was a camel, and it was designed with the cab above the boiler, which creates more friction on the driving wheels, allowing it to climb steep mountains. In the middle, we had the Shay, which was designed with articulated gears so that it could really go up steep curves as it went around, coal country and up steep mountains. And then we end up with something like Sweet Tooth. This was Domino's Sugar, and it was designed to move cars around rail yards, and it pushed the hoppers full of sugar, particularly here in Baltimore. We also have, while the engines were evolving, we also have the railroad infrastructure. So when we look at the tracks, the railroad, the B&O Railroad, experimented with granite railroad ties to capitalize on the local resources of the area, and before turning to iron. And this reflects a granite switch Point Frog that was recently excavated. They just found this like a month or two ago in Patapsco State Park. And this was, ultimately changed to iron, but it has just been unearthed. And then, we have, of course, the Thomas Viaduct, which was built by Benjamin Latrobe. And in 1835, it is the world's oldest multi-arch stone railroad bridge and the nation's first arch bridge built on a curve. And people really at the time thought that it couldn't happen, and they called it Latrobe's Folly, but it is still standing today and is still being used by CSX today. Then, we have, this is a clearance car, and it was a tunnel clearance car that they made. It was essentially, these were like, I call it like a porcupine, but these were quills that would stick up, and they would have it run through a tunnel, and that would tell them, whichever one was pushed down, the height and width and whether other cars could pass through or not. Then we move, obviously the roundhouse, this is our B&O roundhouse, but, with working turntables and other technology that they developed at the time. And as you all know, you can stick a car in the center, and if it's perfectly balanced, one person can actually push the turntable. The freight car evolution, just going to show this to you quickly through Smithsonian. These were Smithsonian National Museum of American History models, probably some of the finest railroad models, and they were donated to us from the Smithsonian. But, you can see up here, we have the wooden gondola flower car from 1832, which, then we have the wooden hopper car from 1880. Then we go down to a steel hopper car from 1897 and eventually get to an aluminum covered hopper car in 1965. And so it really shows the evolution of, wood bodies are replaced by durable iron and steel. And then they start to get the new innovations of chutes that were designed to make, at the bottom to make unloading easier. And we had the same evolution with passenger coaches. Just very quickly, this first one over on the left, we see a car that was made for the director of the General Mining Company of Nova Scotia. It was built in the mid 1830s, and it is likely the oldest surviving personal coach in the world. And it was most likely drawn by a horse. And then in the center, we have an Imlay car. Richard Imlay built these in 1830, and again, most likely built by, most likely pulled by a horse. They look like stage coaches, except for on wheels. And the remarkable thing is people say that 40 people could sit in this car. It's got the same thing on the other side. It still seems rather remarkable, even given that people were smaller then. And then on the right, we have a Civil War passenger coach, the number 21. And by the time we get to the Civil War, we were starting to see passenger cars take a familiar shape and look, though they still had no air conditioning or heating. And the car was built with a cupola roof for airflow and with cast iron stoves for heat, until we get to Olive Dennis and Willis Carrier. And in 1929, B&O Engineers Service Olive Dennis, who recently was inducted into the Inventors Hall of Fame, and Willis Carrier of the Carrier Appliance Company, got together to design the world's first railroad air conditioning unit. And he actually had a secret shop on our campus because they didn't want other competing railroads or appliance companies to know. And they came up with the first air conditioner for railroads. And we have a letter in our archive from Willis Carrier that says, basically thanking the B&O for that job, because he accredited it with launching his company Carrier Worldwide global HVAC. So it is interesting. And then we continue on just to show again the flow. Essentially, you've got the first one over on the right, which was considered luxury at the time of 1890 with no electricity. Kerosene lamps would be, hung, no airflow. And then we go over to the 3316, which was a luxury Pullman car built in 1949 that then had air conditioning and it had comfortable chairs. And, it tells the story of luxury rail travel and actually the Pullman porters. And it, didn't take that long. Telecommunications, I'm going to pass through this, but, we do know that the first telegraph message went along B&O lines from Samuel Morse. It also created a lot of the first telecommunication companies were owned by the railroads. And I'm not going to go through the merger for this one, but that's another really good overview, though, of how the railroad industry really created the telecommunications industry. We get, mail cars. They really were the predecessor to modern day Amazon trucks. They allowed people to put their parcels and letters directly into the car. This one is from the Ma and Pa Railroad. And then we have electrification, with the Howard Street Tunnel and other areas as well that came into play. And timekeeping, our clocks and times and time zones came from the railroads. Refrigeration, that's another major technology that obviously moved freight forward. The earliest cars were, there was no refrigeration. And then we ended up putting some fans in the cars, putting ice in them, and they were called reefer cars. And then fans went in them that made them chill a little bit longer so they could go a little bit further. And then we ultimately got to the cryogenic cars, which used liquid nitrogen. And then we really saw freight start to move substantially around the country, and it's really credited with why the bananas are our favorite fruits. This car, just as an FYI, was the Mickey D car. It carried McDonald's French fries. So for us, concluding and moving on to the other speakers, we are about to open an innovation hall in January. It will focus on the present and future of railroading technology. The future is safer, faster, smarter, and more connected. And so fast, we will show and demonstrate the propulsion technologies like maglev technology, hybrid technologies. We will have drones showing how they're going over the tracks. We will look at the sensors that are being used. The whole goal is to be able to show the public that the railroad industry is advancing because they don't know that. And all of these will be interactive, smart. We're going to have a huge data wall. We're working with RailPulse so that people can get an idea of the magnitude of the freight and also be able to, look at and answer questions based upon this massive data wall that they see. We're going to also have a interactive rail car exhibit that highlights the different types of sensors that are on board these freight cars and what a freight car of the future looks like. We're going to have high-speed train that gives people an idea of what it feels like to go 300 plus miles an hour. And we're going to also do a light race where they can, choose your different propulsion technology and see which one goes faster. So there's a lot more technologies that we'll have, but also obviously that are out there and being developed. But the purpose of the hall will be to showcase the present and future of railroading technology for the public and the types of careers that one can pursue. It's not strictly engineers and conductors and yard work. There's also all the software and the designing that all of you know. So we look forward to you joining us in January 2027 when it comes online. So
Wonderful.
Thank you. I'm going to stop sharing. I just don't know how.
Thank you so much, Chris. I'm really excited to see all of that. It looks really cool and shares, the message that we're trying to convey today, right? So I'll pass it along to our next presenter, Josh Ragland at Norfolk Southern. And all right, there you go. He's got his slides up. Take it away, Josh.
You see the slides now? Just double checking. Okay.
Yes, indeed.
No, great to be with you, Betsy. Thank you for having me today. What a great panel, and congratulations, Chris, on the announcement. Very exciting. So I'm going to cover just kind of some innovations from kind of the standpoint of Norfolk Southern, but also from the sustainability angle. Um, why do we do sustainability? Why is it important for companies? It's really about satisfying stakeholder demands, but it's also just good business sense, right? It's about taking care of our people. It's about taking care of the environment, and it's about making money. It's about saving money in some cases. So it really drives long-term success. We really need to look at projects and innovations through those three lenses. At Norfolk Southern, these are the five pillars of our sustainable strategy as we think about what are the areas that we can impact the most. So carbon is decarbonization, facility is all of our built infrastructure, circularity, great story there. The rail industry has very low, very high waste diversion rates. And a lot of partnerships, partners with folks that are on the panel today and others as we think about how do we drive change across the industry. And then for Norfolk Southern, it's how do we think about our land assets differently and nature-based solutions. So those are kind of the five areas we work in. But as you are aware, is innovation technology is key to unlocking the future in all of these areas. One of those stakeholders I mentioned was customers. Customers, it's very important for them to drive sustainability across the supply chain. For Norfolk Southern, ongoing investments in our fleet, we just completed our 1,000th DC to AC modernization last year. And we've also made some recent announcements of further fleet investments going forward. Data is very important for our customers as well. How do we, collect data and provide that to them? Data they can trust, use for reporting, but most importantly, use for making decisions about how they move their product. And then innovative programs like Rail Green, which a book and claim program, the first in the world, to allow us to pass along the emission savings from our use of biodiesel blends along to our customers as well. And then, getting accolades from that for those advancements as we continue to work with all these partners going forward. So modal shift, preaching to the choir here, but most of you know that rail has a strategic advantage when it comes to truck, not just in efficiency, in fuel savings, but also in safety as well. So our data supports that rail is actually up to 7 times more fuel efficient than truck, lowering emissions up to 90% in some cases. To put that in miles per gallon perspective, on some of our more efficient intermodal routes, we're moving containers at almost 45 miles per gallon. So that's equivalent to a Honda Accord, but with 15 to 20 tons of freight on board. We estimate our customers annually avoid around 15 million metric tons of emissions by using freight and avoid over 8 billion truck miles. So that's a great story that we need to continue sharing across the industry and with all of our stakeholders. We do have a climate transition plan. All of the 6 Class 1 railroads have science-based targets. Our target, we've got 3 main levers here. It's going to be fuel efficiency, biofuels, and renewable energy. That will get us close to meeting our current near-term target, but we're going to need other tools in the toolbox as we think about going net zero or making this target more aggressive. What does that look like? Here's just a few of the potential pathways on the screen here. There's probably at least a dozen more that are being explored as well. Right now it's biodiesel, it's renewable diesel. That's kind of the near-term target, but it's also other things. I'll talk about our pilot project here with Remora on the next slide, but it's also about the battery technology that's advancing, including hybrid locomotives that can reduce fuel consumption on the main line up to 20%, some cases 40%, through recharging the batteries through regenerative braking. Autonomous electric rail cars. There's a number of folks in that space, including Parallel, who you hear from on the next speaker. And then, of course, hydrogen is one of those propulsions of the future. It's just very expensive right now. The actual product is compared to diesel fuel. So, but there's just a few of the pathways going forward. This partnership with Remora, so they are based outside of Detroit, Michigan, actually started through a partnership we have with the Plug and Play Tech Center. I met the CEO almost 6 years ago now. He was working on Class 8 trucks, actually taking the exhaust, capturing that, taking away carbon dioxide and also NOx and PM. And we talked, and he had 5 employees at the time. He had a patent and was just starting out. And I said, when you get ready to really scale this, reach back out to me and let's talk locomotives. And so he calls me back up about 2 years ago now and said, I've got a mobile unit mounted and we're capturing over 70% of the CO2, over 90% of the NOx and PM. And so that we've agreed to pilot that unit. What's interesting about this is it's actually a revenue generating project. So they're capturing the CO2. So to put it in perspective, a mainline locomotive uses around 200,000 gallons of diesel fuel a year, fueling up about once a week. So that potential, the amount of CO2 that would create is around 2,000 metric tons. So if you can capture 70% of that, that's 1,400 metric tons of purified CO2 that you can take and repurpose, selling that to users such as the food and beverage industry, the medical industry, concrete. There's a lot of industries out there that need CO2. And so why not be able to capture that and resell that product into the industry? So it's a really creative solution. There's some videos on their website that you can take a look at as well. And we've got a few podcasts that we have done. The other solution I want to share with you is our progress in digital train inspection portals. And this is taking together all the work that we have done around data analytics, combining that with AI and machine visioning to really, in this case, drive safety solutions. But we also use AI for customer solutions as well and driving operational efficiency. So you can see a picture here of one of our DTI portals. We've got 10 systems installed to date. They're utilizing, these incredible cameras, incredible lighting, ultra high resolution images, 1,000 per rail car at real time speed. So really advanced technology here. We're up to over 80 algorithms now, utilizing machine learning and continuing to progress this as well. It's really how do we augment what humans are already doing with technology and identify defects, prioritize those. It's all about how do we support our mechanical department, our employees. And so think of collecting a health card for every single rail car every time that it passes through one of these portals. Really advanced technology. We led the industry at the lowest mainline derailments last year. Huge improvement since we've installed these DTI portals. Here's just a few more images of the technology, the portals there on the left. This is a location where you've got tracks in 2 directions. You can see the cameras and the stadium lighting there. And then the next slide here just gives you an idea of what the images look like. So these images are being processed by the machines, and the machines will send, if they find a potential defect, then they send that to our network operations center in Atlanta for an immediate response. Some of these are very proactive measures. Some of these are maintenance issues that can be taken when that rail car gets to a mechanical facility. Others may be issues that are critical that actually leads us to stopping a train and doing further inspections on that. So definitely it's an advanced technology for reducing mainline derailments. And the last one I'll point to is the automated track geometry measurement systems, or what we call ATGMS. It's really, providing sensor technology, lasers, images, from underneath the locomotives. So we've got 25 locomotives equipped with this technology now, where you can actually look at the track under load. So it's really about how do we predict maintenance opportunities. In some cases, we can predict that maintenance, the rail maintenance, up to 5 years in advance. So it's really about, supplementing the manual inspections that are already happening, but also being able to, look at the track while you're out there operating on the line of road, without delaying any other trains and so forth. So it's a really advanced technology. And yeah, we're just getting started with a lot of and these are just a few of the measures that we're taking to advance innovation and technology within the industry. And I'll close there.
Thanks, Josh. Really good stuff and interesting through seeing it through the framework of sustainability as well. All right, I'm going to hand it over to Guchan now, and I have to, let me see, let me share your slides. All right.
Okay. Yeah. Good afternoon, everyone. Thank you for having me. Excited to be part of this special event. My name is Guchan Özbilgin and lead perception at Parallel Systems. I want to talk about a specific piece of what driving innovation in this industry right now, specifically sensor and AI, what they make possible for rail, which is safer, efficient, and greener way to move freight. This is not a concept, but something running today. Yeah, let's start with what we are building. We can play the video. Yeah, this is Parallel. It's an autonomous battery electric freight train. No separate locomotive and no new infrastructure. It's run on existing rail network. We started in 2020, mission to give industry a safer, more efficient, and sustainable alternative to short-haul transportation. And now you are seeing it isn't as a concept, it's a live FRA-approved pilot running today in Georgia. So these are a couple of videos from the platooning, vehicles that work together without couplers, forming platoons that scale up to 50 vehicles, each carrying a 40-foot container and rated up to 80 tons. They make contact through the bumpers with just enough gap between to improve the aerodynamics. So every vehicle in the platform is also sensing and communicating with others, coordinating braking events in real time, which is part of why the safety is important, and this can stop 1/5 of a conventional freight train. What you see is a command center, remote supervision. This is where our innovation scales from one vehicle to a network. A remote operator overseeing routing, dispatching, and movement planning across the entire fleet, not just a single vehicle platoon, but entire fleet. So every vehicle feeds back with the full camera coverage to the operator, including long-range narrow field of cameras that operator can see very down to track, which is far beyond what conductor could see from a cab. And this is obviously combined with GPS and inertial data, precise enough to place a vehicle within centimeters where it needs to stop. So that's what lets one person coordinate whole fleet safely in real time. And all of this visible to life with the telemetry. So exact position of the vehicle, sensor health, battery states, everything's running, being streamed through it. So this is the part that I most care. So with full sensing coverage, cameras and LiDAR working together, even total darkness, every vehicle maintains complete situational awareness around itself. Sensing is only half of it, but there is a AI and physics-based algorithms that take all the raw data and actually make sense of it, detecting what's out there, classifying it, understanding whether it's a real hazard or not, and constantly watching it. So for the next slides, I want to zoom into what's the perception and autonomy means for us. If you get the next slide, yes, thank you. So let's zoom in on our sensors. So this is the part that I know best, and this is what lets the vehicle understand the world around it and how actually a vehicle work. So we got cameras covering narrow, wide, and ultra view field of views. So whole area around the vehicle is covered. LiDARs gives us a 3D picture, and I mentioned in every lighting conditions with the long range units. We have GPUs and IMUs with several receivers, and high-end AMUs are getting us the centimeter level positioning and pose. We also have microphones on board too for the acoustic sensing and the whole layer of health sensors underneath all of that, watching pressure, temperature, vibration, voltage, multiple readings continuously. And all of this runs through GPU class high performance edge compute with full sensor fusion happening on the board. Obviously, we have multi-carrier LTE, Wi-Fi, and satellite connectivity to keep everything with every vehicle connected, every fleet connected. And that's also feeds into the real-time telemetry that I showed moments before. If you get the next slide, please. So how this sensor data actually becomes a decision. So this is the core of the autonomy and the perception algorithms. So it all starts with sensing. Obviously, we have cameras, lidars, GPS, IMU feeding continuously. But from there, so we have independent AI models and physics-based models to detect and understand what's actually inside of the data with the tracking information. So we are building this whole machinery with AI models, like developing the AI models with the physics-based cross-checking to understand broader sensing of the scene. And this gives us an idea of like whether fall volume is clear or not, whether switch is positioned correctly, are the signals are conditions right. And based on that, it decides stop, slow, alert on board in real time. And one more step that you see there is just the supervise, right? So a remote operator sits outside that loop, reviewing and declare vehicle to move again after a stop. So AI decides very fast. A person still has final to say for this day. If you go to next slide, please. So how do we know all actually works and how we are building, like how we are improving every single miles? This is the data flywheel that we are building internally. So every run generates fleet sensor logs in real data, real vehicles, continuously coming in. And what's trained to the next generation of the perception models. So data are coming in, our models are getting improved with every single data that we are encountering it. On the top of that, we are augmenting this data to cover the rare case scenarios. We are building to generate something synthetically as well to cover the rare case, edge case scenarios. And before reaching out to any vehicle, this goes through a release process where we are checking how we are doing with the data itself. And once it's out there, field data from the every mile feeds it right back to the same collection. So models keep continuously improving long after it's already deployed. What you have seen in the command center before as well, every decision made there becomes a data too. So that closes the loop until it's getting better and better. Yeah, next slide, please. So this is all to sum up. This is a system built to safe, scalable, and clean. And perception and sensings are what make the autonomy behind it actually work. So that's piece I wanted to see you today. So thank you for having me.
Thank you so much, Guchan. For our final presenter, I'll turn it over to Dominika. And I wasn't sure, did you want me to put your slides up or?
Hi, Betsy. Can you see my slides?
Oh, yes, I can. Perfect. Great.
Hi,
Take it away.
Yeah, my name is Dominika Dubinsky. I'm Assistant Director Operations Technology at CPKC. And I will present on our broken rail detection system. So CPKC uses a broad wayside detector network as one of our primary safety technologies to identify mechanical and engineering defects before they become incidents. And across our network, we have more than 780 mechanical detectors and over 2,400 rail integrity non-vital overlay inspection systems, which are referred to as broken rail detectors. So around 60% of our network is CTC, centralized traffic control, which uses track circuits to detect trains and give signal indication which govern traffic. And in signalized territory, broken rail detection is a byproduct of CTC. And 40% of our network is non-signalized or dark territory, where there are no track circuits and therefore no broken rail detection. However, we often run high-risk trains or dangerous goods through the dark territory. And to increase safety of our operations and reduce the risk of incident caused by broken rails, our team developed a low-cost broken rail solution, which is 80% cheaper than traditional CTC solution. So as you can see in the picture, it's a really simple setup consisting of a helical pile mast, solar panel, and antenna. And one box. The box contains broken rail detection and communication system. And then each detector has 2 wires connected to rail, so 1 per rail. And these detectors are installed at 1 mile intervals, and they are able to detect broken rails 2 miles on either side. So because they are installed at 1 mile intervals, if one of the detectors stop working, the neighbor is still able to provide broken rail detection. So that's how we eliminate downtime. Also, the communication system is a mesh system, which uses cell service, satellite, and radio to account for various conditions across our network. And then on the right-hand side, you can see typical signal response. So when the train enters the detection zone, axles of the locomotive short the circuit and the response goes down. And then when rail breaks, circuit opens and the response goes up. So all these alerts are automated and they go directly to our operation centers. And when we receive broken rail alert, all trains approaching the location of suspected break have to stop and await results of the inspection of by track inspector. So once track inspector determines if it's safe to proceed, they follow the movement over broken rail instructions. And if it's not safe, they just follow the standard engineering procedure to fix the rail. And on the map, you can see our broken rail detection network. So we have over 2,400 detectors in Canada from coast to coast, and then in the States from Minnesota all the way to Louisiana. Additionally to broken rail, the system has ability to detect loose joints, pull parts, and also it monitors its own health, such as disconnected cable, poor charging, or communications issues. And we work with local manufacturer here in Calgary for large-scale productions. On this slide, you can see findings from this system. We are able to detect clear breaks, breaks over tie plate, breaks in joint, pull apart, and loose joints. And currently we have around 90% success rate detecting breaks. So it's really the combination of the technology and track inspector that help us reduce number of broken rail derailments. In addition to our traditional broken rail detectors, here you can see next generation wayside detector. So we modified broken rail detectors a little bit and installed them at mainline switches, which allows us to detect switch point position. So we are using them as switch circuit monitors. Also, we added low-cost wayside temperature sensors, which are installed directly on those broken rail detectors and are spaced 1 mile at 1 mile intervals. And they measure wheel temperature, bearing temperature, ambient temperature. Also, we are able to detect fire on the train or in the area. And also, our team internally developed optical AEI, automated equipment identification reader, which provides car IDs. So then we are able to match the data of rail cars and locomotives better with our safety data. And they also have temperature readers on them. So that's addition to our hotbox detectors to measure bearing temperature and wheel temperatures. That's all I had for today.
Thank you so much. Yeah, thank you so much. Let's see. I'm now going to introduce Devin Lids from the AAR to round us out with a bit of a policy framework for, the sort of policies we need to be in place to encourage all of this great innovation.
Thank you, Betsy. As we kind of referenced earlier, next year is going to be 200 years of freight railroads in the United States. We're all very excited about that. And as Chris kind of referenced, when people think of railroads, they tend to think of the railroads they saw as children or that their grandfather worked on back in ye olden days. But as our speakers eloquently spoke about how railroads are modernizing and innovating all the time, these technologies are designed to complement, enhance, and guide the work of our railroad employees. And industry is working to empower our workers to become fixers rather than finders and focus on the work they are trained to do, whether that be fixing wheel bearings or repairing track or restoring brakes. Um, we've seen a lot of benefits to these new technologies. According to last year's FRA safety data, 2025 was one of the safest years on record for freight railroads across a bunch of key categories, including derailments, equipment-caused accidents, track-caused accidents, and employee injuries, which is all phenomenal news on our way to get to zero accidents. In the environmental space, every year that I've worked here at AAR, it seems like our fuel efficiency numbers have improved. Josh spoke about the carbon capture program that NS is piloting and some of the other technologies that railroads are working on to get us to zero emissions. And we've been excited to see some of these zero emission locomotives be deployed out and in pilot programs. And we're excited to see what those results come back as we work towards a zero emissions future. However, the downside of having such an old industry is we still have a lot of old regulations on the book that haven't kept pace with all this technology that we've been developing and talking about here. At AAR, we believe that freight policy should encourage innovation across all transportation modes based on measurable outcomes and not try to pick winners and losers based on how we used to do things or on political leanings. Policymakers should let innovation occur, let data drive decision, and let safety outcomes be the goal. A good but somewhat complicated example of what we're how we sort of think about this would be how we've worked with automated track inspection technology. About a decade ago, railroads started to participate in pilot programs that would deploy machine or automated track inspectors called ATI. That Josh referenced this earlier. That could be added to a train and would inspect the track in real time as the train was moving and delivering other cargo. As part of this pilot, the number of manual inspections would correspondingly be decreased. And I should know that ATI tech systems cannot detect all the types of defects that manual inspections can look for, but they can detect other ones particularly well. And the pilot programs had really promising results. The ATI systems found the type of defects that it's designed to look for at much higher rates than manual inspections had previously found, and instructors were freed up to focus on other areas where they're better equipped to handle, and they could also focus on fixing problems that the ATI was finding. The pilot programs generally saw a lot of defects being detected early on, and then the railroads would go and fixed it, and then towards the end of the pilots, you would see better overall track health. So we innovated a new technology, tested it out to try to use it, and saw really positive results. And AAs are also these positive results that occurred when new technology was allowed to be used to complement our workforce, and sort of thought about it as something we should be using more frequently in our regulatory structure. We should be piloting new technology and seeing the results, then deploying it more. Unfortunately, since then, we've seen certain FRA administrators or administrations block the necessary waivers to deploy these pilot programs, and we've seen legislation from Congress that would lock in current regulations on visual inspections into law. More recently, we have seen the FRA allow us to do these pilot programs again, which is a great sign, but we're really concerned that this is not how a regulatory system should work. The rail regulatory system should be based on performance and rather than specific operations. In an ideal world, regulators would set a strong safety and operational standard for our railroads and then give railroads the ability to identify the best processes, operating systems, and technologies to meet these goals. The regulation should be based on data and sound science and should encourage innovation without locking in existing technology and processes. Currently, other modes of surface transportation have embraced more performance-based regulations, but our regulations are still bogged down from stuff from the 60s, 70s, 80s, and 90s. And the congressional side, recently, the House Transportation and Infrastructure Committee marked up their version of the surface transportation reauthorization, which is where you see a lot of stuff around safety and funding for programs. We were concerned that we saw too many provisions that would lock in current operating practices rather than allow railroads to incorporate the technologies that we've been sort of talking about today. For example, there's provisions locking in the current visual manual track inspections and other provisions dictating how staff crews are, which we see as a step in the wrong direction. These provisions would just drive up costs for railroads and our customers without any corresponding safety benefit. Overall, rail policy should be targeted and justified by data and tied to a clear operational safety need. The markup was just a first step in a long legislative process, but we thought it was the wrong step, and we're going to continue to work with legislators to more constructively find policy outcomes that will support our networks and support the American transportation network.
All right, perfect. We have 9 minutes for questions. I see a couple of questions here. And just a reminder to type them into the chat or Q&A if you have them. For Dominica on broken rail detection technology, how are you keeping wayside vandalism or vandals, I guess, from stealing or damaging many sensor units?
I have to say that that's what we were concerned before we started installing them, but there weren't many instances of vandalism. There were only like 5 solar panels stolen, and in that location we installed AirTags on them. There was more damage done by animals, so we had to add metal jackets on some of the cables. But because these detectors are mostly installed in dark territories, which aren't like as densely populated, I think that's what's keeping the number of vandalism instances low.
Interesting. Good question. To everyone, I guess, on the panel, looking ahead 5 or 10 years, what would excite you the most? What innovation excites you the most? I could, let's see, who should I call? Josh. I see you came back on.
Yeah, I would say, projects like what Parallel is doing is really exciting. If you think, the rail network, in US is 140,000 miles long. How much of that's actually occupied at any one time by trains or crews? It's a fairly small percent. So if you think of how could you add capacity to existing networks, I think it's a really innovative solution, and it's yeah, definitely something of the future. I just set you up, Guchan.
Yeah, I didn't want to gloating over our technology developing, but I'm super excited as well. I'm coming from self-driving vehicles industry, and I see the gap for the autonomous vehicles, especially like the trains. We are pushing very towards all the self-driving cars in the industry, like to becoming autonomous, safety, scalable. But why we are not doing that on the rail? So like this is super exciting. That's why I'm here with the parallel systems as well. I totally agree with you.
Buchan, I'll just keep going. What has surprised you the most in working with railroads to deploy this technology, like in the rail space?
Yeah, I think the one big challenge is like we need to operate in every single condition, right? So like compared to autonomous vehicles right now, those are in very specific conditions, very specific regions. They are working on it, but when it comes to rail industry, so we need to keep running 24/7 with all the weather conditions, extreme weather conditions. I will say there are unexpected animals can come onto the rail from out of nowhere. Maybe interactions between the agents are easier compared to autonomous vehicles, but there is one big challenge in the autonomous vehicle. You can always nudge into the space that you can swerve through it, the empty space. But in rails, we are literally on rails. People say that maybe it's an easier problem, but you need to be very accurate to say that, am I going to hit this target or not? Because you don't have any wiggle room to make a little bit steering on the rail. So that's the precision and accuracy. It's very important.
Interesting. I'll throw one to Chris. You walked us through some of your museum's collection, which was really neat. Do you think there's one particular innovation that has had like a bigger impact on railroading in general, or a couple of innovations you'd point to? Oh, I think you're muted.
Well, I'll just give a short answer, but if you think about it, the diesel engines, they're still the workhorse today of the freight world. So, I mean, it's starting to change, but they've been the workhorse for over 100 years. So that's an invention that stayed for a long time.
See, I have a specific question for Josh. Curious what image sizes are coming from the DTI portals and how long they're retained. Just
Yeah,
trying to
actually
get
just
an idea of the
yeah, I actually just
storage.
responded in the
Oh,
chat.
sorry.
Yeah, I don't know the exact size, but we've got a whole innovation page on our website, and I put the link in the chat. And there's also links to videos in there as well.
Perfect. Let's see. Let's throw
I think
one
we
to
have some of our technology team on the call too, so they may be able to add that to the chat.
Great. Let's see, one for Devin on policy. How does current transportation policy help or hinder innovation? And I think you've spoken to this, but maybe another real world example or
Yeah, let me give the example a little bit more depth on ATI, and I apologize for going back to that, but I just did a lot of reading about it, so it's top of mind for me. If current policy dictates how often you have to do a visual inspection of a track, and that's prescriptive. There's no inherent flexibility in that regulation unless you get a waiver. If we stayed with sort of that prescriptive method, we would never have been able to determine sort of the correct balance between how often we should be doing visual inspections, and how often we should be doing automated track inspections. And because we were able to do pilot programs, we were able to sort of triangulate more about how we can use our person's time more valuably and how ATI can complement that person. So again, walking a track takes a lot of time. If you have to do that twice a week or what have you, that's a lot of time you're not doing other things. And if we sort of have these prescriptive regulations the way that regulations tend to be in the rail space right now, we just wouldn't have had the flexibility to find better ways of doing things. So we really want to have regulation that say, okay, improve your track and defect rate by 10% next year, and then we can figure out exactly the best way. And that's sort of what we want to move towards in the long term, medium to long term.
great. A question about how these emerging technologies and innovations are coming to, as they're coming to fruition, are we baking in cybersecurity? How are we addressing cybersecurity vulnerabilities? I don't know if any of you could speak to that in particular.
Yeah, I mean, every railroad has a cybersecurity team, and they work both with themselves, each other, and with AAR to sort of come up with the best practices around cybersecurity and what we're seeing. I also know the federal government has a law program, CISA 2015, that allows for greater cooperation between not just railroads, but private sector in general and the federal government about best practices around cybersecurity. So we've been working a lot on that to make sure that law gets extended. And I know that all of our railroads talk about that stuff all the time and communicate with AAR and each other on sort of the best practices and making sure that their networks are protected from cyber incidents.
Thank you. I had missed one for Guchan. How well is the accuracy and precision of the parallel detection methods with LiDAR and cameras maintained in precipitation and fog?
Yeah, it's a great question. Maybe the person who asked the question knows maybe LiDARs can degrade with the fog and also the rain. But one thing that we are using, it's like we are using multiple echoes from the LiDAR, not just like one return. So we always know like if there's a occlusion of the LiDAR and if we are stopped, like the sensing range is reducing, we are getting into degraded mode, which means like we are going at the slower speed and things like that. LiDAR is just an additional factor on the top of the cameras. So we have full sensor fusion with the cameras and LiDARs. So they complement to each other. But we have all kind of degradation methodology, and from the data that we learn and the sensors that we are using, newer sensors that we use multiple echoes from the LiDAR to see even actually beyond the particles as well.
Well, I think on that note, it is 3 o'clock and I like to keep time. So, thank you all so much for joining us. I will just, as I noted at the start, GoRail runs the Rail Champions Grassroots program. And as part of that, we have an action center where you can email your members of Congress or contact, you could call your members of Congress. And we are running a campaign right now around what Devin discussed, the Surface Transportation Bill and some of the policies that policy frameworks that would enable railroads to keep innovating. So if you are interested in that, I believe we've dropped into the chat the link to the Action Center, or we'll be doing that soon. And we will also, as I said, share the recording afterward with all of you. So thanks again to all of our panelists. Really interesting stuff, and congrats to Chris and the museum. And thank you all. I hope you'll join us soon for another program. Bye.
Thank you.
Thank you.